So question number 3, it involves maximizing and minimizing problems. You are given a function, and what you need to do is to find out what is the interval where the function is increasing and decreasing, and also what is the interval where the function is concave upward or downward. Now, the first thing that you need to do is you have the equation and you need to differentiate. Can you please differentiate x to the power 4 minus 18x squared? Please differentiate the equation. Differentiate x to the power 4 minus 18x squared. Can you do that now? After you differentiate, you have to try and solve for the derivative equal to 0. Okay, so most of you have 4x cubed minus 36x. Now, equate that to 0 and solve. Equate that to 0 and solve, please. All right, so as I mentioned, you have the function, you differentiate and you equate that to 0. So if you differentiate 4x squared minus 36x, the common factor is 4x. If you take out 4x, what's left? Sorry, x cubed, not x squared, x cubed. What is left? X squared minus 9. X squared minus 9. Can you factorize x squared minus 9? What do you get? X minus 3 and x plus 3. So we have we have 3 x values. 4x is equal to 0. Another one is x minus 3 equal to 0. And another is x plus 3 is equal to 0. So one of the x value is x equal to 0, and x is equal to 3, and x is equal to minus 3. All right, so do you think this is your final answer? No, it's not. It's asking you to find the interval where the function is increasing and decreasing. So that means this here, these are values that help you, these are the turning points for the graph. So what we need to do now is you place those values. You have 0 and you have -3, which is on the left, and you have +3, which is on the right hand side. Okay, so you have 3 values. How many intervals do you have on the number line? When I say interval, I'm referring to this region. This is the interval. Interval less than -3. This is another interval. Interval between -3 and 0. Thank you. Everyone gets the idea. 4 intervals. This is another interval between 0 and 3, and another interval is greater than 3. Okay, so the 4 intervals, we have to find out whether it's increasing or decreasing. And we've done this earlier on in question number 2, but we're going to use the same idea. So you get a number that's less than 3. Can you think of a number that's less than 3? Okay. You take that number and you substitute into the derivative. So let's take, for instance, minus 5. So you take the minus 5 and you substitute into the derivative. You take the negative 5, put it into the derivative. Is your answer positive or negative? Negative? Everybody else? Do you agree? Negative? Yes, it's negative. So that means I'll remove this and I put minus. So that means it's decreasing. It's decreasing for the values less than minus 3. Now choose a number between negative 3 and 0. And then substitute that into the derivative. Okay, f dash of negative 2. Put negative 2 into the derivative. Do you get a positive or negative answer? You get a positive answer. So is it plus or minus? I'm going to put plus. I'm going to put plus. So I remove this and I put plus. So that means between this interval, it's increasing. Now choose a value, our next interval, choose a value between 0 and 3. 1, okay. Find f dash of 1. Put 1 into the derivative. Find out if your answer is positive or negative. Negative. I'm worried about my low-value students. Are you guys okay? No one is responding to my messages? Anyone? Guys? Okay, okay. Yes, it's minus. So I will put minus. And the last one? Choose a number greater than 3. Thank you for saving us that trouble. Yes, it's plus. Right, so remember for this question, the number that you choose, you have to substitute into the derivative. Do not put it into the original function. You have to take the number and you put it into the derivatives. The other thing is you can't use 3, 0, or positive, negative 3. Okay, the answers that you found, you can't use this again. You have to choose numbers that are not 0, 3, and minus 3. Is that clear? Okay, so keep that in mind. And the last one is positive. So that means how many intervals is positive or is increasing? 2 intervals are increasing. And where is it increasing? Or can you give me the interval in mathematical term? Or in English, between minus 3 and 0? All right, in English, between minus 3 and 0. But mathematically speaking, you have to write it as minus 3, comma 0. That's the interval. Bracket minus 3, comma 0. And what about the next one? How am I going to write this as an interval? It's from 3 and all the numbers greater than 3. So bracket 3, comma positive infinity. So it's increasing when I read it, okay? When you give me the answer, when I read it, I'll read it as between -3 and 0 and all the numbers greater than +3. So from 3 to positive infinity. All right, can you give me the interval for decreasing? Mathematical terms, please. How are you going to write the interval? Between 0 and 3? Between 0 and 3, 0, 3. Set. And what about the next one? It's from negative infinity to 3. So you write negative infinity, comma, -3. Right? This part is 3 to positive infinity. Right? This region. This region is -infinity to 3. -3, sorry. All clear? Do you understand how to write intervals? Okay. Next, can we move on to the second part, concavity? Find out where the function is concave up or down. All right, that's the first part. So this is your answer to the first part. Now let's move on to the second part. And the second part says the interval where it is concave up or down. Right. You ready for this? Now, we have our function f of x is 4x, x to the power of 4 minus, what was it? 18x squared. To find increasing and decreasing function, we differentiate. F dash of x, we found 4x cubed minus 36x. Now to move on to the concavity, you have to differentiate this again. So f double dash of x, that is equal to 12 x squared, and minus 36x, the derivative is 36. Any questions here? The first step. All good. Now equate this to 0 and solve for x. 12x squared minus 36 equated to 0. So when you equate this to 0, the common factor is 12. And then you have x squared minus 3. All good. And then divide both sides by 12. So 0 is equal to x squared minus 3. And if you solve this further, x squared is equal to positive 3. And take the square root. So x is equal to the positive and negative value of square root 3. All set? Any questions? Again, does this give the interval for concave up and down? No, it doesn't. Okay, so that means our x values, one is x is equal to positive root 3, and another is x is equal to negative square root 3. So draw the number line. All right, draw the number line. And we're going to put our values negative root 3, and we put positive root 3. What is the decimal value of square root 3? Square root of 3, what's the decimal value? 1.73. So that means you have to choose a number that is less than negative 1.73. And right, how many intervals? We have 3 open intervals. So choose a number less than negative 1.73 and choose a number between. And then who did that? 0.73. Right, and substitute into the second derivative. Yes. Okay. So for this interval, is it plus or minus? Plus, minus. So do, 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 do. you substitute into f double dash. F double dash. So this one here would be plus. This is plus. Yes. Let's go to terms here. Both these two are plus. So if we choose 0, this becomes minus. So the idea is if f double dash of c is greater than 0, if the answer you get is greater than 0, it's concave up. If f double dash of c is less than 0, it's concave downwards. Okay. So our interval for concave up. So we write down concave up. The interval, two intervals, negative infinity to root 3, negative root 3, and positive 3 to positive infinity. And concave down, remember concave up or concave down is between negative root 3 and in positive 3. All good? The next one is logarithmic differentiation. If you have a look at our question for logarithmic differentiation, you'll notice the power is an exponential function. I've just put across questions where you have an exponential function as the power. So know how to differentiate an exponential function. If you don't know how to differentiate an exponential function, then you'll have problems. So we are going to look at question number 2b. Let's try number 2b. Y is equal to 3x minus 2x cubed, and the power is e to the power 3x squared. So with logarithmic differentiation, the first step is to take the ln on both sides. So ln y is equal to the ln of 3x minus 2x cubed to the power of e 3x squared. Next, apply the rule to the right-hand side. The rule says you can bring the power to the front, so we have 3e 3x squared ln of 3x minus 2x cubed. Any questions? Ln y is equal to e to the power of 3x squared ln of 3x minus 2x cubed. Now we differentiate both sides. The derivative of ln y is 1 over y times dy over dx. And the derivative of the second function, this is f. Mind you, this is f. And the second one is g. This is f and this is g. So f times g dash plus g times f dash. Is that clear? F times g dash plus g times f dash. I'm going to show the working here. So f is e to the power 3x squared plus, times g dash. The derivative of ln 3x minus 2x cubed is 3 minus 6x squared over 3x minus 2x cubed plus G times F dash. G is ln of 3x minus 2x cubed. Multiply that with the derivative of the exponential, and the derivative of the exponential is 6x e to the power of 3x squared. So now we simplify and we make dy dx the subject. So dy dx is equal to 3 minus 6x squared e to the power of 3x squared over 3x minus 2x cubed. Any questions here? Does anyone have any question? How am I going to write the second part when you combine these two? Which one will come first? What will come first? 6x, and then we have ln 3x minus 2x cubed, and then the exponential. All right, so make dy dx the subject. That means I have to take the y to the opposite side and times. So I multiply everything with y. I multiply everything with y. So my final equation is now dy dx is equal to the same equation, but in place of y, you put the original. Plus 6x, the natural log followed by exponential. And then you times this with 3x minus 2x cubed exponential and 3x squared. All clear? So this is your final answer. Go through your test one. Most of you, I've asked you to go over your test one paper and go through the corrections, because these are the same concept that you will see in the final exam. So please go over your sample, your test one and test two. Do the corrections, because that's basically going to help you in preparation for your test, in addition to the sample paper. So we'll move on to the last part of question number 3. Okay. So u is equal to 3x squared minus 2 in the first equation, and in the second, the third part is u is equal to 5x cubed minus 2. I want you to differentiate, and the derivative is usually given as du over dx. So du over dx, what is du over dx for the first part? That is equal to 6x. So, 1. Okay, so I'll explain this again for the sake of our recording. Right, so number 1, select u, differentiate u, which is du dx, and make dx the subject. What you're going to do is replace u and dx into the question or into the problem. So now we have to integrate negative 5x squared, u to the power of 10, and du upon 9x squared. So dx is now replaced with du upon 9x squared. That's why we have this part. And then what we need to do is simplify. When you simplify, the x squared will cancel. The fraction is negative 5 over 9. And now all you need to do is to integrate u to the power of 10 using the rules of integration. So the rules of integration says when you integrate u to the power of 10, that is u to the power of 11 divided by 11 and plus c. So when you multiply the fractions, you get negative 5 upon 99 u to the power 11 plus c. And all you need to do is replace u with the original equation. So negative 5 upon 99 and 3x minus 3x squared minus 2, 3x squared minus 2 to the power of 11 and plus c. This right here is the final answer. The next part, integrating negative 4x squared upon 5x cubed minus 2 dx. So first you select u is equal to the denominator, which is 5x cubed minus 2. Du dx is equal to 15x squared. And if you make dx the subject, you get du divided by 15x squared. So if I rewrite the equation, it is negative 4x squared. The denominator will be u, and dx is du upon 15x squared. So we simplify. When we simplify, x squared will cancel. The fraction now becomes negative 4 over 15. And what are you integrating in this case? Is it u or 1 over u? Right, so integrating 1 over u, again, when you integrate 1 over u, you use the formula sheet. Integrating 1 over u is ln u, and don't forget, final answer, you replace u with the original equation. So negative 4 over 15 ln of 5x squared minus 2 plus c. Any questions? Before we move on to, all right, so now we'll move on to question number 4. Question number 4. So please, you may leave this session and join me for question number 4. So I we will start around 10 past 1. Yes. 10 past 1. Right now it's 12:56. Here in Fiji it's 12:56. So we'll start at 1:10 p.m. Okay? So just about 10 minutes. Yeah, 10 minutes. So join whenever you can. And if you'd like, you can start answering questions. Other than that, we'll start at around 10 past 1. We'll discuss question number 4. Thank you.